Alright, so let's talk about evaluate reverse polish notation. So you're given the string tokens, and then basically you just have to do the mathematic calculation. So let me just explain what just happened. So you have 4 different operators, and then basically, there are some constraints that this will not be any division by 0, something like this, right? So what's the idea? So the idea is actually behind this question is by using the stack, right? So I have to traverse from the beginning all the way to the end, and then when I have the integer, right, I just keep adding into the stack until I see the notation. And then if I see the notation, right, 2 and 1 you plus, so it's going to be 3, right? This has to be 3. So when you add it, when you equal to 3, right, you have to push into the stack. But the problem is, well, you have to push into the beginning, right? Because if you have a integer follow on or the notation follow on, right, you want to do the mathematic calculation correctly, right? So in this one, I'm using the array deck, not a stack, but array deck. And then just keep adding the integer into the deck, and then if there is a symbol, you mean the operator, right? You just add, just pop the first 2 and then add, right? But when you add into the array deck, right, you want to add the first, right? You want to add every single integer at first. So it's gonna be 2, right? And then you 1, right? So this is current array deck, right? And then you see a symbol, so you pull these 2 out, right? So this is the first one in the deck is the what? It's the second number, and the second one you pop is what? Is the first number you add, right? Right. So the order doesn't matter, because when it comes to the minus, right? 1 minus 2 doesn't equal to 2 minus 1, right? And 1 divided by 2 doesn't equal to 2 divided by 1, right? So the order matter, right? Just think about this, right? Alright, so I'm gonna just start porting array deck, right? And put the integer into it, right? So I'm gonna call deck equal to array deck traverse a string token. Alright, so if a string is equal to the operator, right? So it's token dot equal. It's gonna be plus, or token dot equal. It's gonna be minus, or I don't want to just keep typing, so just copy and paste. And it is gonna be multiplication, division. And then I'm going to say, if this is happening, I need to have the number out, right? So the second is going to be the deck.remove first. The first number, right? And then the first number is going to be what? The second remove, right? You have to think about it, right? And then once you have it, then we can do the calculation just based on the token. So if token that equals plus, and then else if for the minus, else if for the multiplication, else if something like this. So I'm going to just copy and paste. This is minus, this is multiplication, this is division, right? For the plus is easy, right? It doesn't matter like which one is going to be the first or second, but every single time you add, right, you combine the 2 numbers, you have to add into the stack, which is the deck, right? So add first plus second, and also the multiplication is still doing the same. Add first times second. When you come to the subtraction, right, the add first doesn't change, but the problem is what? This is going to be what? first minus second, right? And the division is still going to be the same. And it's going to be first divide by second, divide second. And then you just keep traversing, right? And then if the string token does not equal to any operator, you add a value into the deck, right? But since this is a string, I need to convert to the integer, right? Alright, so you might be wondering what just happened when you want to return, right? So you will keep adding every operator, every result operator into the array deck, right? So there should be the one element left in the array deck. So you can just say array return deck remove first, right? So this is going to be the solution. So let me see. Oh, I forgot something like this. All right. Okay, so let's talk about the time and space. This is going to be a space. You add every single element, the string token, into the array deck, right? So space is going to be all of them. Time is going to be all of them. Traverse every single string token. And yeah, so let me just give a pause right here using debug mode, start debugging. And just see the windows on the left. And then you just keep looking at it. Right? Since 1 and 2 are integer, right? The order you add to the deck is what? You add first, right? Then you see the operator. And when you want to pop, right? It's gonna be pop like this, right? And this is the order, right? And when you keep adding, you add into the deck, right? So you have one element left. So I'm using the skip forward one. Then you will be the last one. The last solution is gonna be 9. Alright. So you might be wondering why you are using if else, right? So you can use in a switch solution. So it's going to be exactly the same. I'm going to just copy and paste because this is extremely similar. So stack.push. In this one, I'm using the what? I'm using the stack name instead of array deck. So yes, so this is going to be exactly the same, right? Stack.pop. So when you add the first two, the first two element out from the stack, and then you push into it. But when you subtract, you want to know the order, right? A minus B, even though this is popping first, right? And then the multiplication doesn't matter, the order doesn't change. And division, right? Division is like this: A divided by B, and then everything else just push into the value. And this is still okay. Okay, I think I need it clear in A and B. Should be good. Yeah, so the debug mode is going to be the same, and then the string, the space and time complexity are the same. You still have to add every single element into the array deck, and then you still have to traverse every single token in the token string array, right? So the next solution is going to be what? Using the bifunctional solution. So it's like Java 8 above, and let's just start coding like this. So I need a hash map. I will talk about this. So map string bifunction integer, and this is going to call operation. We go new hash map. Alright. So what does this mean? String represent my what? The operator, plus, minus, multiplication, division, and then bifunctional represent my what? This is what? The first one, the second value, and this is the result value, right? I need to do the multiplication inside my BiFunction, right? So since this is static, I'm going to declare my operation setup output plus, and then you have to say a comma b. This is going to be what? A plus b, right? And then do this exactly the same stuff. Minus a minus b, right? Multiplication a multiplied by b, division a divided by b. Alright. So sorry, this has to be what? Out of the function. And let's see what let's see how we use operation map. So we still have to what? Using a stack for integer. We still have to traverse a string token. And then we still have to what? Find out the number, right? So it's gonna be nums2 equal to what? The first one in pop. And the first one is gonna be the second pop, right? So I need a BiFunction before I put into the operation, right? So it's gonna be what? BiFunction. I'm just copy and paste. I'm gonna call op equal to operation .get by token. So if the current token is plus, right, I will get this formula inside my op. Then I will using the new value going to call result equal to what? op.apply nums1 comma nums2. So this represent A, this represent B, right? So A, B, A, B, A, B. I already find out that what just happened. So I need to put the nums1 and nums2 correctly into my what? Into my operator, right? Then I will just add the value back into the stack, which is going to be a result. But I still missing one stuff. This is what? This is when you see the operator plus, subtraction, multiplication, division. But what happens if you see the integer only? So which is going to be what? Which is not the addition, not the subtraction, not the multiplication, not the division, right? So if you cannot contains the value token, if any token does not inside my operation key, I need to add into the stack. Then I will just what? Continue to skip this one, right? And again, you have the last value inside the stack. So you can pop, you can pick, doesn't matter. But in this one, I'm just going to, submit. Alright, so this is using BiFunction. It's more advanced, but it doesn't matter. And then you declare the operation earlier before you traverse. And when you see the operation that contains key, if you didn't see it, which means it's going to be integer, right? And if you didn't inside the if statement, which is going to be what? The token, the multiplication, the subtraction, division, and then you pop. Right? But when you pop, you have to pop by order because you already declare your function BiFunction correctly, right? So you just apply nums1 and nums2 into the BiFunction map, right? So this is the solution. So time and space are the same, but the way you code is going to be the different level. The first one using the if else is going to be like beginner. Using the switch is a little bit advanced, but it's still beginner. But using the BiFunction solution, which is going to be the advanced, and probably you are more proficient in Java. So this is a solution. So if you still have question, leave a comment below, subscribe if you want it, and I'll see you later. Bye.